I'm from the United States. I'm actually from a town called Atlanta. It's located in the state Georgia, so Atlanta, Georgia. It's in the southeastern part of the United States. A little company you may have heard of called Coca-Cola resides there as well. So I am a developer evangelist at Microsoft, and essentially what that means is I get to work with emerging technologies. So our product groups are building software, and typically when they're kind of in some of the earlier stages of the release cycle and they want to actually work with some customers and do some proof of concepts and things of that nature to see if the software works or what's wrong with it, if they're headed in the right direction, that sort of thing. My team, which Joe and I, we typically go out to customers or partners and we'll build projects with them. So we sit down and code with different customers and partners on, the newest technologies. And then I go around and talk about some of those experiences. So beyond that, I work a lot with Docker. So I've been working with Docker for quite some time. And I work with the ASP.NET team, and particularly on the Docker part of it. So you're in a good spot for that. Now, I do want to take just a quick second and get a little bit of audience participation from you. I have just a couple of very simple questions. The first question is, how many people here are developers? Aha, excellent. How many people here have worked in ASP.NET? Even better. And then the second to last question, how many people here have worked with Docker? Perfect. You all are in the right spot. Okay? Even if you've worked with Docker, you're still in the right spot. Now, last question. Who here is having a good time at Code Europe? Everybody, come on. Yeah, there we go. All right, no more hand raises. That's your workout for the day. So this is a fun talk. It's a short talk. I'm not going to take a whole lot of time. We've got like 80 slides. No big deal. No, not really. It's like 10, seriously. And then a couple of cool demos, and then we're off to the races. Now, notice I'm using a Mac, okay? And this thing has just been giving me nothing but trouble, right? Surprising, Apple giving Microsoft problems. So when I'm like switching back and forth between my demo, I'm not going to do that. I'm going to go through all the slides, and then I'm going to do the demos because I'm going to have to like fix my screen resolution settings to make it project correctly, okay? So you'll have to just bear with me for just 1 second while I get that fixed, but I think I know how to do it, and we should be good. So a little bit about me personally. These are my kids. I've got 3 of them, and they all write code. So, I have little helpers. They check in and fix my bugs and stuff like no. My oldest one actually does, and the little ones they will be. I collect masquerade masks, just kind of a random geeky thing. It's all like counterculture stuff, like V for Vendetta. I've got them all over my room, and I'll put them on. I'll chase the kids around. It scares them. It's good. I did actually work in the Azure product group. I was on the media services team. I did really boring work. It was like telemetry systems and stuff like that. But I got to live in Las Vegas for quite a while. And actually work with like NBC and Delta Tray and some of these very large worldwide broadcasters working on projects like the FIFA World Cup and the Olympics in 2014 and that sort of thing. Also, I cycle a lot. That's my thing. Gets me out behind a computer and whatnot. Now, if you do want to get a hold of me, this is my contact information. You can find me on Twitter. That's probably the best place to find me. At tripdubroot. Now that comes from IIS. Anybody ever see that little folder in inetpub called www.root, triple W root, tripdubroot? Okay, so we get where the tripdubroot comes from. My email, it's a pit of sorrow. So you can email me, and I will try and email you back. But I get thousands of emails a day, so it's kind of difficult to maintain that cadence. All right, so let's jump right in, and let's tell the story behind ASP.NET for a minute. So it sounds like a lot of people have worked with .NET or do work with .NET in the room. So I won't spend a tremendous amount of time on all of the history, but we started out in 1.0, right? And this was like at the turn of the millennium. And basically, we released 1.0, and it did not work. I mean, comes down to it, it did not have a lot of the libraries and things that you needed to actually have a functional framework. So very quickly we released 1.1, and that's kind of what everybody thinks of and remembers as the very beginning of the .NET framework. And then we really hit the nail on the head when we got to .NET 2.0. .NET 2.0 was probably the most mature, got everybody's attention, pulled most of the Java developers away from Java that we were going to pull, you know, that sort of thing. And then we went on to start adding on some what we called modern features of the framework in 3.0 and 3.5 with WCF and WF and WPF and all of this stuff. And we had the Silverlight fiasco, right, and all of that kind of good stuff. So what we've done since then is very, very interesting. And this all started with the ASP.NET team. And you probably all remember, you know, Scott Hanselman and Scott Gu coming out and saying, hey, we're open sourcing ASP.NET, right? And that was really cool, very cool. And since then, Satya Nadella has joined as the CEO. He came up from that group. He did my job, 20 years ago. And so I'm hopeful. But so they had a very strong roots in open source. So when all that happened, a lot of this freed up for Microsoft. We kind of got out of this closed culture and kind of got into a more open culture. And what they did was they took the .NET framework, the 20 or so years of experience that we have with the .NET framework, and created what they called .NET Core. And essentially what they did was they started from the ground up and did a rewrite of .NET. And they open sourced it. And they built it so that it can be cross-platform. That's why I can stand up here today in front of you with a MacBook and actually demo writing .NET code, because it runs directly on the Mac, which I think is pretty amazing. I started 6 years ago at Microsoft, and things were very different. I had to have a Windows phone. I had to have a Windows laptop. I couldn't talk about Linux, this sort of thing. But now, most of the work I do is in the Linux world. So this is great. I get to go back to what I know really well and whatnot. So now, in typical Microsoft fashion, we did what we normally do, and we made it confusing. Okay, so you have .NET Core. You have ASP.NET Core. It's .NET. ASP is still part of .NET, so okay, we'll kind of put that to bed. And then you have Entity Framework Core. I'm going to show all of these things to you in a minute. But we did this thing where we have what we call the .NET Framework. That's what I just went over that history. So we know the .NET Framework. It's what we all know and love. And then we have .NET Core, which is the open source cross-platform version of the framework. And yeah, it's not complete. 1.1, does it sound familiar? We had 1.0, didn't really work. 1.1, .NET Core actually works. And then 2.0 is about to be released, right? It's a release candidate right now. And so you have Core and you have the framework, and you have this other thing called .NET Standard. And what does that mean? Well, .NET Standard is literally just that. .NET Standard is a standard that talks about how much of the API is compliant between the two, framework and core, essentially. Okay? It's literally, you open up, you look at a matrix, and you're like, okay, .NET Standard 1.6 is .NET Core 1.1 compliant and Framework 4.6.1 compliant. And essentially it goes through and says this property or this method on this class is required or optional in the frameworks. Okay? So we're trying to kind of give you a little bit of a map between the two. And if you run this .NET Standard code, it will run as framework in this version, or it will run as .NET Core in this version. And there's a little bit of a gap between the two right now. But what happens in 2.0 is it's all going to converge. They're going to be both 2.0 compliant, and we should stay like that going forward for the foreseeable future, and it should all become a lot less confusing. Then you can write in .NET Standard on both sides of the platform. All right, so we get rid of some of that fragmentation, and that's the goal of 2.0. It's very exciting. I'm very excited to see to have a complete framework again in .NET Framework Core. In .NET Core. Okay, so that's my .NET spiel. We're not going to spend a whole lot of time on .NET in this talk. I did just kind of want to explain kind of what the ecosystem looks like right now and talk a little bit about the differences between Core, Standard, Framework, and all of that, because it can be kind of confusing. But containers, Docker, right? The world has gone mad for this. It really has. And it's a great tool. It's a great tool. I like to think of this mainly as a tool used to deploy your back-end systems. Okay? It's kind of like what the App Store did for the iPhone. Docker is doing for us back-end engineers and getting code out to servers very simply and very easily. So Docker, kind of the history of Docker is kind of interesting. So it originates from a company called .cloud. And Solomon Hykes was the CEO of that. And what .cloud was it was a PaaS cloud provider. Very similar. Anybody know of Heroku? You've heard of Heroku here? Some? Okay. So it's just a PaaS provider. They don't have virtual machines or anything like that. It's meant for you to take your Ruby code or something of that nature, or Java, and just ship it straight into .cloud. And what they would do is they would wrap these containers around it and use that to deploy it out to their PaaS instances and scale and things of that nature. Now, to hear Solomon talk about it, and I met him a couple of times. I work with Docker very closely and been all over the world with them. And just most recently, I was at DockerCon working on some of the videos with them that they have out on their YouTube channel. So if you go to the YouTube channel, you'll see me doing a lot of the interviews and things like that. But as you know, you're looking at Solomon, really cool guy. You know, he shows up in like flip-flops and sweatpants and gives a keynote address. You know, you're just like, this guy's nuts, man, awesome. But I think it was like 2013. He was at a Python conference. He got up on stage and started screaming about Docker, this thing called containers and Docker. And essentially what he did was he took the tooling that they were using in .cloud and open sourced it as Docker. So containers are nothing new in the Linux world or the BSD world. Containers are just simply a set of tooling around namespaces and C groups that makes your life very simple once you get it configured, but it makes your life hell to configure it. If you've ever tried to work with any of these types of toolings without using something like Docker, it's a nightmare. I would highly recommend, like if you really want to understand how Docker works, going and taking a look at those tools. But you know, just know you're going to pull your hair out if you do that. So essentially what he did was he said, okay, this environment, the Microsoft's getting into it, Google's getting into it, AWS, they're all pricing themselves to the bottom. You know, storage is dirt cheap, compute is dirt cheap. So why do I want to be in this business? I want to make the tooling that all of these clouds use. So that's what he did. He open sourced Docker, and I started playing around with Docker in about 2014. The story on Windows was horrible, so you had to have Linux. Satya joins. We can start using Linux, so I start playing with it a little bit more. And we move on to, it captures even Microsoft's attention. How do we make this work with Windows? So in about 2015, we partnered kind of quietly with Docker and started looking at how to actually start porting Docker over to Windows so that we can have Windows-based containers. And then in 2016 at DockerCon, we came out and officially announced our partnership with Docker. And we started to show, kind of the first part of what Windows containers would look like. Now, I'm not going to be showing off Windows containers here because you can't run them on a Mac. But with that said, let's take a little time and define what Docker kind of is and looks like. So there's two things in Docker that you really got to understand. The first one is there's a engine for Linux. There's a Docker engine for Linux, and it runs Linux-based containers. Easy enough? That's where Docker came from. The next piece is there's a Windows-based engine, and it runs Windows-based containers. That is the Docker world right there. When it comes down to it, you have a Linux engine and a Windows engine, and they run containers. So it's PID 0. All the containers underneath that become PID 1, PID 2. They don't know about each other, but they think they're an entire operating system. But when really they're sharing resources with the underlying operating system. Now let's get into actually what is a container. And I think the easiest story is to compare and contrast them with virtual machines to really kind of try and understand what the differences here are. So we're all very familiar with virtual machines. You have a bare metal box somewhere, right? And then you install Windows or something of that nature on top of that. And then you put your hypervisor. Of course, you're using Hyper-V, right, if you're in the Windows world. And that enables you to virtualize the hardware between the host operating system and other operating systems that you install on top of it, the guest operating systems. Now I have a complete install of an operating system that I then put my machine in, or I deploy my application to or whatnot. Now the problem with VMs was they made the promise that we're going to be able to provision virtual machines in hours, and we're going to be able to, and our IT departments are going to be able to give us the machines that we need when we need them, right? And to some extent, maybe that happened. But from what I saw, for the most part, it still takes a few weeks to get a virtual machine because you go and you request that from your IT department, and they're like, oh, we got to order more machines now. So they got to then go buy bare metal boxes, set those, yada, 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 right? And it almost problem gets exaggerated. Now you contrast that whole setup with containers. Containers are very interesting in that there is no hypervisor. So take out the hardware virtualization. The container is literally running as a process on the operating system. It's just a process. And it's sandboxed off from the other processes around it so that it looks to itself like it's its own operating system. It's its own independent operating system, just like a virtual machine would be. But it's not. It shares the underlying file system, and it shares the underlying kernel. So when I say you have a Linux engine that manages these containers, and I say you have a Windows engine that manages these containers, and containers share the kernel with the underlying operating system, that right there should tell you that a Linux container cannot run on a Windows operating system, and vice versa, okay? Easy enough. Now, what we do in the Windows world to make that happen, or in the Mac world to make that happen, because remember, Mac, yes, it's a Unix variant under the hood, Darwin, but it is not Linux, right? It's not Linux. So Docker for Windows, this is not the engine, this is the install that you would go and download and install on your machine, or Docker for Mac, also not the engine, it's the install that you go and set up on your machine. What that does is it sets up a virtual machine under the hood. So on the Mac, it sets it up in Xhive, and on Windows, it sets up a Linux virtual machine in Hyper-V. And then it just connects the CLI tooling on your local machine to that and obscures away from you. It hides the fact that you're actually connecting to a Linux virtual machine on your Windows box. So when I say Docker run Ubuntu, it's actually running that container in a virtual machine on my Windows machine. Now, there is a little checkbox there. If you check it, it says use Windows containers. That switches Docker for Windows over to using the Windows engine. And that's running natively on your machine because it's a Windows box. It can run Windows containers. And it just switches it from the CLI tools from pointing at your Windows, or excuse me, at your Linux VM, pointing to the Windows engine running on your machine. Okay? So I think everybody kind of gets that. Docker for Windows, Docker for Mac, the engines, and I will try and refer to them as that. Another interesting piece that you want to understand is that the file system it uses, it's literally sharing the operating system files under the hood. So the DLLs in System32 are shared with the container inside of the Windows container. Now, if you make changes or additions to those to inside the container, it does what's called a copy on write. So when you try and write to a shared file between the container and the host operating system, it makes a copy of it in the container, and your container gets a little bit bigger. Okay? It stops sharing that between the container and the operating system. Another interesting thing, when you're making a Docker file, each statement in the Docker file itself is an image layer. And I will show this in a minute, but if I'm writing like an apt-get command or something like that, or a PowerShell command in a Windows Docker file, and it fails, I can literally grab the name of that failed layer within my container and mount it as if it were a container and look inside of it and see why did that just fail. It's really cool. And I'll show you that as we come up. This enables some very interesting things that I can then, this would be the Ubuntu base image, right? I can then take that and add on top of that other read-write layers by putting commands within a Docker file. And essentially, once it's finished building up the container for me the first time, it just kind of smushes it all down into a single container. And I'll show you what that looks like. Okay, so I ran through all of this already, so I'm going to go ahead and just jump over this slide. We covered all of that in gory detail. A couple of other things to note about this world are there are things called orchestrators. And essentially what this allows you to do is set up a cluster of nodes for Docker, right? And as developers, we hope that we don't have to understand this, but you find yourself like having to deal with this occasionally, even as a developer. This isn't just for the ops guys anymore, right? So I like to kind of point this out. There's a thing called Docker Swarm. Docker Swarm is what we call an orchestrator, and it allows it to schedule your containers out to different nodes in the cluster. It does some other things, but that's basically the idea. Docker Data Center is built on top of that. It's their enterprise version of Docker Swarm. It adds a lot of tooling, a nice web UI, and things of that nature on top of Docker Data Center, but it costs money. Docker Cloud is kind of their own little cloud-based Docker environment that you can use. And there's other tooling and things that you can look at in the Docker ecosystem that will make your lives a little easier. Now, if you're using Visual Studio 2015, there is a Docker extension. You can go out and install the Docker extension. It adds what's called Docker support to it. You get this little context menu when you right-click on your project and you click Docker support, and it will basically new up and write you a Docker file. Now, that extension is rolled into Visual Studio 2017, so you get that for free. So when you're using .NET Core-based project types within Visual Studio, Docker support will work. This isn't for, oh, I'm building a WPF app or a Windows Store app, I get Docker support. No. This is for .NET Core applications. That's it. Okay? The next piece there is, of course, Visual Studio Code. Should be everybody's favorite editor, right? Yeah? That's what's up. All right. I love Visual Studio Code. I'm a paying customer for Sublime Text, but I have fully committed and made the switch over to .NET Code. Now, Visual Studio Code, sorry. Visual Studio Code does have a few different extensions for Docker, but the main support Docker extension there gives you syntax highlighting as well as IntelliSense for writing Docker files, and also gives you some Docker commands directly within the IDE, so you don't have to shell out to the console or anything like that to run Docker commands. You can actually run your Docker commands like Docker build, Docker run, that sort of thing, directly from Visual Studio Code. With that said, you can also debug from inside of Docker containers. Now, I'm not going to show that off because it takes a little bit of a configuration to make that work. Essentially, you have to add the remote debugger inside of the container and some things like that. But there's plenty of documentation about how to make that work out there. Speaking of that documentation, here's a couple of great places. If you're interested in Docker and you want to get started with this, go out, take a look at the Engine User Guide. That's on docker.com. Docker Tools Docs is another great place to go out and look and see some of these third-party tools that enables really neat scenarios inside of Docker. The example voting app is probably a great app to look at the very beginning. Okay, it's got pieces and parts of it written in Python, pieces and parts in .NET, and another language. So it's kind of set up as like a microservices type of thing. It's really kind of cool. And then you have .NET Core Lab, also a great place to look. So with that said, I'm going to go ahead and start moving into the demos. Hopefully my demos don't do what this building is. And remember I told you that I'm going to have to, you're going to get a black screen probably here in just a second. Yeah, okay. So let's see if this works. Okay, beautiful. Was not as painful as I thought that might be. Okay, so let's dive in. And I will make this bigger, don't worry. Okay, so let's dive in and let's start with Docker itself. Okay, so if I run Docker PS, you'll see there, you see that okay? Everybody good? In the back, you good? Okay, excellent. So if I run Docker PS, that's just going out and say, hey, list out what containers I have running. And as you see, I have no containers running. And that's basically what we want. Okay? So if I say Docker run hello world, if I could type, what that's going to do, excuse me one second. All right, Docker run hello world. What it's going to do is it's going to first look locally at my machine to see if I have the hello world image downloaded already. Okay? And I did initially, and it just ran my local image. So I went and removed it real quick and then reran that same command. And you see up there, unable to find image locally, going out and pulling it. So Docker has a repository out on the internet at hub.docker.com called the Docker Hub. And in here are a bunch of container images, right? And essentially these are official images, and then there's community-driven images as well located here, that if I need to run a Redis cache, an Nginx, I need to run Ubuntu, Alpine Linux, MySQL, any of this type of stuff, I can just go out and execute Docker run, and let's do it. Let's run Nginx. It's a small one. Docker run -d, daemonize it, run it in the background, right? Open up port 80, point that at port 80 on the in the container, and give me an Nginx. Now I should have this locally. And basically what I did was I just stood up a web server right there, an Nginx web server. Now there's configuration files and things like that within that container, and I can do volume mounts of local folders in place of those configuration files and have my configuration files for this container locally on my machine and just mount them inside of. It's kind of like a storage area network mount inside of a virtual machine. I can do the same thing here inside of a container. So now if I go out to my local host here, I should see welcome to Nginx. And this is just the HTML files for this are just located on the file system inside of the container. And I could just remove them and copy my own in if I wanted to. All right. To do that, that would look like, let's see here. Actually, yeah, let's do it right here. I'll come into Pixel Playoffs. This is one of the things that I was talking about this morning. In the Playoff app, this is a React.js app, and I have a Docker file in here. And in that Docker file, you see that it pulls from the Nginx image that I just showed you. And I just cd into the working dir within the Docker file where the HTML files are located and all my my web files would be located. And I copy whatever gets built from my React.js pipeline over to that folder. So it copies all my web files in there. And then when I ship this off, it's 3 lines. And you see it, this works great. It really does. I ship that off into Azure or Google or AWS, wherever I want to place it, and stand that up just like I did here, and I have my web server up and running in just a few lines of code. And this enables very interesting scenarios for your operations teams to move around your code between different environments. Test, staging, prod, you get the idea. Now, that's a little bit about Docker. I'm going to go ahead and remove that. So if I say Docker PS, you'll see that I've created the name Cranky Allen. Now this is actually generated. It's got 2 different word dictionaries, some nice verbs there, and then some names. So it'll always be some kind of silly, cranky, mad, happy, ecstatic, these types of descriptive words, and some pioneer in technology like Gates or Wozniak. Now if you look at the code, Docker's written in Go, but if you look at the code that actually generates these names, you'll see there's a little Easter egg at the bottom, and it says if you ever generate the name Boring Wozniak, loop back up and regenerate, because Wozniak's never boring, right? So I thought that was a nice little treat there. But I'm going to go ahead and say Docker PS-A, and you see a couple of other things listed there. You see 2 versions of Hello World listed there. Those are containers that have stopped, essentially. So what I'm going to do, I'm just going to clear everything out. I'm going to say Docker, and I'll just grab this, Docker RM, paste that in, and -force, because it's running, I have to force it to stop and then remove it. And then if you just want to remove everything, you can say Docker RM, and this is kind of a bash thing, but you would say Docker PS-AQ, which lists all of the containers, but only their IDs. That's what the Q does, is, hey, just give me the IDs. Okay, so enough about Docker. Let's go to my temp directory here and say .NET new MVC-O code _EU. Okay, so .NET new MVC output to the code _EU folder. Okay, so now what this is doing from the command line, I'm generating a new .NET Core MVC web application. So if I go ahead and jump into code EU, you'll see that I have all of these, and I'll go ahead and open up code. Oh my gosh. And we see we get, it's just file new project, right? What we've come to know and love. So this is, a standard workflow for getting my .NET Core, whatever type of application that I'm going to be working with, up and running. Even in Windows, we're pointing people to the command line quite a bit. But you don't have to do that. Visual Studio 2017, you can just go in and say File New Project and choose .NET Core, and you still get the same old interface that we know and love there. And this is just asking me to do a NuGet restore and all of that. I'm going to close this because we're not going to actually run from that. What we're going to do is we're going to use Visual Studio instead of Visual Studio Code. But wait, you say, you're on a Mac. That's correct. We now have Visual Studio for Mac. This is something that's kind of new, and it's been getting a lot better over time. Now, what Visual Studio for Mac is not feature compliant with Visual Studio. Okay, it's just not. What it can do is it can run iOS and Android development using Xamarin and supports .NET Core, kind of what you'd expect. Will more stuff be coming in the future? Oh, I'm sure. But for now, this is kind of where we're at. And I actually already have a very small application. Now, recently at DockerCon, I was hanging out with the SQL Server for Linux team. And they're all there talking about how they've containerized SQL Server for Linux. I'm like, oh, this is cool. I want to check this out. So let's do that. So what I'm going to do, I'm going to run a quick command here, and because it's a bit of a bear of a command, I just keep it copy so I can copy and paste it. And we'll look at this real quick. It's docker run -e. E stands for environment variables. So these are environment variables I'm passing into the container. So when this opens up, there'll be an environment variable except EULA, and it will equal Y for yes. So I don't actually have to accept the EULA manually. Okay? And then it gives the super secret SA password right there. Okay? And opens up port 1433, names the container SQL Server, puts it on the network.net. So I've created a network here called .net, and it's an SDN network in my machine. And then it runs the Microsoft / MS SQL for Linux container image. Okay, so I'm going to go ahead and just run that. And let's say docker network ls. And in here, you'll see I have a list of Docker networks. Only one of those is one that I created. The other ones you get for free out of the box. You have bridge networks, host networks. There's also what's called an overlay network. And this is essentially networks, SDNs, running inside of containers inside of Docker. That's what these are. And I created .NET, and what that gives me is its own address space with its own DNS server. So any container that I give a name and I mount it to this .NET network will come up and register itself with .NET, giving me service discovery. Pretty cool, right? So now I get service discovery in the form of DNS, kind of out of the box. And what that means is instead of, in my code here, in the application JSON file, instead of pointing this at localhost, what I can now do is address it by name, SQL Server. Because remember, that's the name of the SQL Server that I gave. Okay? Now in here, let's take a look at this real quick, what this code will do. Notice that we rolled in dependency injection by default in ASP.NET Core. So now any service that I configure in the configure services method will get passed to my controllers. Okay, so now all of these services I have available to me in my controllers because this is an MVC app, right? And that means that I have this DB context, which is using Entity Framework 7, Entity Framework Core, that works with .NET Core. and allows me to talk to SQL Server very simply, very easily. And you'll notice there that I have, it's just a simple POCO class. We're not going to go and look at that student POCO class, but what we will do is we'll come in here to the school context and take a look at that real quick. And you see I just inherit from DB context. I have one table there that will be created when this model is created. You don't have to do that if you use EF migrations. I'm doing all of that manually here. Essentially what I'm doing is I'm initializing a database and just seeding data into it very quickly without using migrations. And then when the application starts up, essentially the last thing that I do is I initialize my database. So I just stood up a Linux container running SQL Server, which is pretty cool in and of itself. And then when this application starts, it will start up, connect to the database, and create my table, and then a controller will just pull the data out of it. Okay, so super simple demo. But what I want to show you here is a couple of things, and this would be kind of the okay, so I'm back into my, oh, nope, I'm not either. So I'm back into my project here for Code Europe. Wow, I can't type today. And in here, this is where you see my Docker file is located. Okay, so if I just do cat Docker file, you'll see there that it's using the ASP.NET Core image 1.1. I'm changing directory into the app, and then I'm copying anything in the out folder over to the container, and then that entry point, that last thing there says, when this container runs, when the image is executed and runs as a container, the command that I want you to start is .NET, and then it points to the codeeurope.dll file. So essentially host in Kestrel my .NET website. Okay, so that's what it's doing. So it runs through, when I run build, it'll go through each one of those steps. And then finally, when I execute, it'll run that, come up, connect to my SQL Server, build out the stuff in that table, and then I should see it all kind of happen if this goes well. So instead of doing everything by hand, I'm just going to copy and paste so I don't make any more typos. .NET Publish, so this is, if you're wanting to release your code and you're writing in .NET Core, this is the command you would use to release your code. So this is going to go out and build my application and remove all the symbols and all of that and get it ready to go. So it goes out, and you see there it creates the codeeurope.dll file. Remember, that's the file that I need. And then I'm going to just run docker build. I've done this before. So I'm putting on the end of this no cache. So that means if I don't put that there, it will use existing images that I've already built previously. But I changed the code, so I don't want it to use those images anymore. So I'm saying don't use the image cache, because that speeds it up. If you can just use the image cache, then do it, because that makes it 10 times faster, because you don't actually have to execute that step any longer. It just uses it from already previously executed builds. But -t is just, hey, give this a name, this image a name, and the name I'm giving it is EU test, and then there's a dot. And that dot says the Docker file is in the local, in the folder that I'm currently in right now, the present working directory. That's all that is. So if I run that, we see it goes out. I've already downloaded the image, so it just uses the image that I have. The next image it mounts is the working dir application. And then it copies my folder, my files that it generated in the step above that into the container image. And then it creates the final entry point container that I can then run. And just to show you, if I mount this, if I say docker run -it, and IT is redirect standard input and standard output of the container to my console here so we can see what it is. And that image ID, we see it comes up, And as I would expect, we've changed directories into the app directory. So I've literally mounted that image right there. So if I had a problem with that, I could just go in here and inspect what's going on at this step, which is pretty cool. And we'll just exit out of that. And then the last thing is we'll actually run this container that I built. And it is docker run -d with open port 8080. And I see a problem there. Give it a name website, so the container will have the name of website. Put it on the network.net. That way we can get that DNS resolution for our connection string that we used. And then run EU test, which is the image that I had just built. Right? So if I run this and I hit enter here, I should now see, let's get this back up to the top. I should now see two containers, my website and my SQL Server. And they should be able to talk to each other. And the fact that my website is still running and hasn't crashed and disappeared from this list tells me that it should still be working. So now if I come over here, I go to localhost. I just got to refresh it. It's cached. And we see it spinning, and there we go. We see it come up, it goes out, hits the SQL server, and pulls that data back. So all of this is running right now in the container. So now what I can do is I can check in that Docker file, or I can make what's called a compose file. And a compose file says, use these Docker files, but set up a network and run them with these commands. So I can basically put in one file all that I just showed you and check that into my repo. And then I just tell my IT guys, I'm like, hey, just say docker compose up. It'll read the Docker file and it'll stand up the system in your staging and production environments. And your deployment and your run book just becomes a couple of Docker files and a compose file and a command. All right? So with that said, that's what I've got for you. I will take some questions.